Hello everybody, this is Javier Lloret speaking, and this is the tutorial that is going to guide us through the first flight simulator practice, which is the conventional navigation practice. This is the practice that we make in our third year course, and this tutorial will consist of two different parts. Our first part of instrument description that I'm going to perform now on the simulator, and then a second one in which I will guide you through the mission that you have to accomplish during the lab, in which you have to perform a local instrument flight departing from Santander following a standard instrument departure, and then ending up in the Bravo Lima Victor VOR, from where you will have to start a standard arrival. We'll go through this later on really slowly to guide you through the different steps. But before that, let's get familiar with the simulator. I have it already open here for us, and well, here you can see the aircraft we'll be flying in the simulator. It's a 737-800, in this case without winglets, of Scandinavian Airlines. Very beautiful aircraft. And well, I'll very briefly guide you through the commands that will help you manipulate the aircraft during the simulator, which are basic for the practice. Alright, so this is the cockpit, and we will basically be working on the EFIS, the Electronic Flight Instrumentation System, which consists of these two panels. First, this one named the Primary Flight Display. Please be aware that when I click on the Primary Flight Display, I can pop it up, and same with this other one, which is the ND, the navigation display. What do we see here? Well, on the primary flight display, we have the anemometer that indicates which is our indicated airspeed, currently 165 knots. Alright, be aware that, as we've already seen in class, the indicated airspeed is very different from the true airspeed that we can read here on the navigation at the top left corner of the navigation display. This is the true airspeed, and solving the wind triangle, we get the ground speed that comes determined by the inertial navigation system that we can read here, currently 184 knots. And the aircraft is solving the wind triangle equation for the wind, and indicating that currently the wind is coming from 035 degrees diagonal 19 knots. Okay, this direction is geographical, not magnetic, although the arrow, since this instrument is oriented towards the magnetic north, or having the magnetic north as a reference, this arrow is represented here with respect to the magnetic north, but not this number. This direction here is giving the direction from which the wind blows with respect to the geographic north. Okay, but these are just some details. So this is the anemometer providing us the indicated airspeed. Here in magenta we see the same value, 165, which is the selected indicated airspeed that we want the aircraft to fly. We can manipulate this value here. Alright, this is the most important panel with which you will be manipulating the aircraft. It's named MCP, the Master Control Panel. Alright, and here you have the selected indicated airspeed you want the aircraft to be flying at. I can put the mouse on this knob here, and scrolling up and down I can move the value. Let's say I want to accelerate and increase to up to 180 knots. I can select 180 knots here, scrolling with the mouse up and down, and you see that I have changed this magenta number here, and the aircraft has accelerated up to 180 knots. Good. What else do we have here? Well, I'll come back to this later. We have the artificial horizon that gives us a clear depiction of what's the altitude of the aircraft with respect to the horizon. This is obviously the current seat angle of about 4 or 5 degrees now. How the x-axis, the longitudinal axis of the aircraft, is placed with respect to the horizon. This indicates the angle of attack of 4 degrees currently, and this is the barometric altimeter. Currently we are flying at flight level 150 which is not the same as an altitude of 15,000 feet, as you already know. And here is the selected altitude or flight level at which I want the aircraft to fly. This is the current reading of the altimeter, and this is what we've already seen in class, and is named the Boltzmann window. It is providing us the reference pressure with respect to which we want our reading to be. Alright, so this is currently in American units, 29.92 inches of mercury. We can change this to millibars, with which we are a lot more familiar with, by moving this knob here that says VARO from inches to hectopascals. We can do that by placing the mouse on the top of the hectopascals and having the hand not white as it is now, but gray. You see, by slightly moving the mouse from white to gray, I changed from one of the outer knobs to the other inner knob. If I put it in gray and then now I click the right button of the mouse, I change the reference from inches to hectopascals or millibars. And if I wanted to go back to inches, I would only have to click with the left button of the mouse. Alright, this way I changed to hectopascals or millibars, and I can read 1013, which equals QNE. Alright, good. Let's say I now wanted to fly an altitude which is below the transition level. Today the transition level at this area at which I'm flying is 70, transition level 70, and I want to be flying at an altitude, let's say, of 6,000 feet. I would just have to select here at the MCP an altitude of 6,000 feet, and then I would be here reading 6,000 feet in magenta, but the aircraft is currently maintaining 15,000 feet with respect to this reference 1013, so it's actually flight level 150. Today's QNH in this area comes determined by this other program that I'll talk about later, and it's 1022. Here is the METAR of Palma de Mallorca, which is the area around which I'm currently flying. So the QNH is 1022. I just have to come back here to this VARO knob, and now with the right hand scrolling it up and down until I select a QNH value of 1022, and that's what I just did. So with respect to this isobar 1022, I was not flying 15,000 feet above, I was flying 15,270 feet above. Alright, because altitude is different from flight level. So this clearly shows how we can mistake ourselves if we don't change our reference pressure when we cross through the transition layer from QNH to QNE, or from QNE to QNH, as I just did, properly. Now if I wanted to descend, I will talk later about what are the commands. I will just have to select the new altitude I want to have, or flight level, which is 6,000 feet. The right pressure reference is set, and now I would just have to click on level change here on the MCP. What's this going to do? This is going to, since this is a descent, what this is going to do is that this is going to reduce the thrust of the aircraft that we can see here. These are the engines, these are the revolutions of the engine. It's going to decrease the thrust of the aircraft, of the engines, and it's going to look for the selected speed of 180 knots with a proper pitch position. So if I click on level change, it's retarding the thrust, you see. It's reducing the amount of thrust, and it is pitching down a little bit and losing altitude down to 6,000 feet. So just by showing you a little bit about the altimeter, I'm also trying to guide you through how to move your aircraft vertically. If you want to descend, just select the altitude you want, the speed at which you want to descend in the indicated airspeed, and click on level change. That will force the autopilot to reduce the thrust and look for the selected speed with a given pitch angle. Alright, good. Let's assume now that I wanted to increase my indicated airspeed while I am descending down to 6,000 feet. What's the aircraft going to do? It's not going to apply thrust to accelerate the aircraft. It's going to look for the new speed, let's say of 210 knots, by pitching the aircraft down. You see how the aircraft is pitching down more and trying to accelerate, looking for this new selected speed that I've established in the master control panel. Good. So far for the vertical level change option. I can also perform a descent at a given rate, at a given vertical speed, and maintaining the speed with the necessary amount of thrust. Let's say the air traffic controller tells me to descend down to 6,000 feet at a rate of 1,000 feet per minute. Remember that we measure vertical speed in feet per minute. What would I have to do? Well, on the MCP here, I would have to select VS for vertical speed, and here I would be reading the vertical speed at which I want the aircraft to descend, and I can select the one that I want. Let's say I want 1,000 feet per minute, and then automatically level change has been disengaged and speed management has been engaged, and now the aircraft is not flying with idle power, it's applying more thrust than idle. You see, it's not at 30% of N1, it's applying a little bit more, 43, 45%. Good. And you see that the altimeter is indicating that we are descending, and the variometer, which is this other reading here, is indicating that we are descending with a rate of 1,000 feet per minute down to the selected altitude. Let's say I want to descend at 1,500 feet per minute. Well, what would I have to do? I would just have to knob this button down and establish the rate at which I want to perform the descent, and the aircraft will automatically descend down to 1,500 feet. Okay, so this has clearly shown how to perform a descent. Let's assume that all of a sudden there is an aircraft below and the air traffic controller tells us to maintain flight level 100. Well, the first thing we'd have to do is to change the pressure, the reference pressure, because a flight level is with respect to QNE. I can do that by clicking here and setting it to standard, and then I can move this all the way up to 10,000. This way the aircraft will level off at flight level 100. Okay, maybe I did this too fast. You will for sure understand how this works along the video as we fly through the local Santander flight. Why did I do this? Because I want to show you how the climb option works. Now that we are leveled at flight level 100, let's assume that the air traffic controller tells us to climb up to flight level 240. How would I do that? Well, similarly, I will change on the MCP altitude button the selected flight level I want to fly at, which is level 240, basically 24,000 feet. 24,000 feet with respect to the isovar of 1013 millibars. Okay, remember that. It's very important to know with respect to which isovar you are flying. All right, and currently we've selected standard by clicking here with this finger. We have moved from 1022, which was the QNH2 standard, which is 1013, or also known as QNE. Good, so I've selected flight level 240, but the aircraft's doing nothing. Why? Because the altitude hold button is engaged. We can also read it here on the top of the primary flight display. It says altitude hold. Let's say I want to climb at a speed of 210 knots and a vertical speed of 2,000 feet per minute. What would I have to do? Well, I would just have to click on vertical speed and then move this to a positive rate of 2,000 feet per minute. Just like this. What's the aircraft going to do? Well, it's going to apply the amount of thrust required to maintain 210 knots climbing at a rate of 2,000 feet per minute. If I've selected 2,000 feet per minute here, it's going to look for those 2,000 feet per minute here on the variometer. Good. And see that the aircraft is not applying full thrust. It's applying quite an important amount of thrust, but not full thrust. So another option to perform the climb is by pushing also the level change option. What's it going to do? It's going to apply full thrust, you see, and it's going to look for the selected speed by pitching up or down the aircraft. So it's finding a seat angle of about 8 or 9 degrees that lets the aircraft maintain 210 indicated airspeed knots with full thrust. If I, let's say, wanted to decelerate and perform the climb at a lower speed, let's say 180 knots, what's the autopilot going to force the aircraft to do? Well, obviously it's going to force the aircraft to pitch up more, reducing the indicated airspeed, and that's what I'm going to do now, just to show you. So I'm going to reduce the indicated airspeed to 180 knots, and you see how the aircraft is pitching up and decelerating. We were flying before at a seat angle of 9 degrees, and now it's pitching up to 12, 13 degrees, more or less, all right? And the aircraft will do this until reaching the selected altitude, which is flight level 240. Good. With these instructions, I think it's more than enough with respect to the vertical controls, all right? Good, but let's continue on the instrument description. So we've already seen the selected altitude, the current altitude at which we are, or flight level, depending on the Kollsman window reading, the variometer, and here we have a lateral indication. It's basically indicating which is what's our heading and what's our track, all right? And currently we are flying on heading 350, so almost north, all right? You can see here in magenta that it's 350 heading selected, and we can change that also on the MCP. Here you can read heading, and you can move this knob to the right or to the left depending on the heading you want to follow. Let's say the air traffic controller tells us to turn right on heading 030 degrees. Well, what would I do? I would place my mouse on this knob, and by scrolling up or down, in this case by scrolling up, I will select a heading of 030 degrees. And what's the aircraft going to do? As far as this button of heading selected is engaged and illuminated in green, the aircraft is going to turn right, looking for the selected heading. You can also read here that heading select option is engaged. Why? Because this button is pressed on. Can you see? If I switch it off, it disappears from here, and I lose all kind of lateral control. So this is very important. Be aware, if you want the aircraft to follow your instructions, please make sure that the heading selected button is switched on, and that you can read it also on the top of the primary flight display. Otherwise, the aircraft is not going to follow the selected heading. Good. And then the aircraft is turned looking for the heading of 030. Actually, it went a little bit more than that and then recovered because of this tricky thing that I was doing to the aircraft. Good. So if we had a strong wind, current wind is only 7 knots, we would see here a difference between the heading and the track. The heading comes determined by this triangle on top, this white triangle. The magenta knob indicates the selected heading, which I can move. All right. And let's place it at 030 again. And then there is this white cross that indicates the track. This is sort of a small aircraft as seen from above, and it clearly shows, or well, maybe here it's very slight, there is a very slight difference because the wind is not very intense, but the wind is coming from the left, and you can clearly see that the track is to the right of the heading because the aircraft is drifting a little bit to the right. Well, currently there is no wind, so there is no drift at all, but before you could see that. Good. So let's continue a little bit. Let's go a little bit southbound, because I don't want to go too far away from Palma, since I want to show you how we can fly with respect to the VOR of Palma. Good. So far I think I've come up with most of the things we can read here. Well, there's something I'm missing, and it is something that I can change with this button here that refers to the minimums of the approach. When we perform an approach, we will later see that there are some minimums. The minimums are the lowest altitudes or heights that we can get without being able to see the runway. All right. So the designer, the engineer that has designed the maneuver is responsible for the separation of the aircraft with terrain if following the maneuver until a certain point. Below that point, the engineer or the maneuver takes no responsibility at all, and it has to be the pilot that, by acquiring visual contact with the runway has to complete the landing. All right, and that altitude at which the pilot has to make a decision and has to decide whether he can continue because he can see the runway or not, is named the minimums. And the minimums can be defined using the radio altimeter or using the barometric altimeter. So that's why here we have radio for radio altimeter or varo for varo altimeter. We can change that knob with the shadowed hand like that. Radio to the left and varo to the right. Let's say I want to select a minimum radio height. So radio altimeter is going to indicate heights, while varo altimeter is going to indicate normally altitudes. So let's say I have a decision height of 154 feet, for instance. What would I do? I would select radio here with the shadowed hand, and then with the white hand I will move it, and you have seen here on the primary flight display how this just popped up, and I'm going to select the radio altimeter, the decision height that I have read on the chart. This is something that we'll do later on the exercise. Well, I can indicate it to you now on the different approach charts here, depending on the type of aircraft. You will read, this is the 737, which is a Charlie category aircraft. You will be reading for a category 1 ILS approach. There is a decision altitude of 367 feet, and here in brackets you can read it in heights, which would be 355 feet. Okay, imagine that the value we'd be reading were 154, for instance, which is the one I said before. I would here place it to 154. So as the radio altimeter reading goes below the selected value, this is going to flash and turn yellow, indicating the pilot to make a decision. Okay, we will play with this during our local Santander flight. Good. So far so good with respect to the primary flight display. Well, there's something else I want to tell you. I didn't explain anything, but currently I'm not flying the aircraft. It's the autopilot that is engaged and is flying the aircraft. This is the master button of the autopilot. If I pressed it like that and disconnect it, this alarm would pop up indicating that the autopilot has been disconnected, and it's myself currently with the joystick that can move the aircraft. See, I'm turning left with the joystick, although you cannot see it. I can pitch the aircraft up, climbing, and I'm manually controlling the aircraft. All right. By pressing Shift 9, you will pop up this other window. Actually, since this is a two-dimensional panel, you have to be all the time doing this Shift 9, Shift 3, Shift 4, these things that I will talk you through the tutorial to look at the different panels. If we were in a real cockpit, this Shift 9 button that I'm talking about is this reading here, all right? But since it's a little bit more complicated to use the simulator using this three-dimensional view, we'll better use the two-dimensional view and pop up the different windows using Shift 4, Shift 3, Shift 9, whatever we need. So if I pressed Shift 9 and I could see this window, here I'll have a reading of the position of the controls. And you can see that if, for example, I want to turn left, the left aileron is moving up while the right aileron is moving down. If I want to recover the turn, I turn right by moving up the right aileron and down the left aileron. And well, these are basically the controls of the aircraft. And the same for the elevator. If I want to pitch down, like I'm doing now, the elevator could move down. And if I wanted to pitch up, as I'm doing now, the elevator could move all the way up. And the same with the rudder, although I currently have no pedals, so I won't show you. Good. You can also take a look here at spoilers. If I pressed the letter C cedilla on the keyboard, I can deploy the spoilers. You can see here how both the left wing and the right wing spoilers have been deployed, and it's also indicated on this green sign here saying speed brakes are armed. Good. Let's take a look at this from outside now that I'm flying the aircraft manually. So yes, so you can clearly see it. If I wanted to turn right, well, you can clearly see how those ailerons moved. If I wanted to turn left, the ailerons would move the other way around. And for the spoilers, which are surfaces that detach the boundary layer and can help us lose more energy, we may have to use them later in our mission. Well, if I press Cedilla, you can there see how these actuators on the top of the wing can be deployed, detaching the boundary layer. Good. I also want to show you how to deploy the landing gear, which is something very basic I didn't tell you before. If I press the G letter on the keyboard, the G for gear, the aircraft will deploy the landing gear, as you can see. Alright. If I pressed G again, the aircraft will retract the landing gear. Alright. Good. This is something you can see at a cockpit with by taking a look at this lever. This is the lever that the pilots use to deploy or retract the landing gear. Good. I've actually gone a little more than 4,000 feet above the altitude that I had selected before. Let's go back to a heading of 180 degrees and flight level 240. Good. And there's something I want to tell you also regarding the flaps. You guys know that aircraft are designed using wing extensions that can help in the provision of lift for landing and for takeoff, and thus increasing the C sub L of the lift equation for the same angle of attack, reducing the speeds at which landing and takeoff can take place. This is something that here in simulator will control using the F7 and F6 buttons on the keyboard. By pressing F7, as you will be seeing now, by pressing F7 one by one, I can deploy the flaps. I don't know if you can appreciate how I am deploying the flaps from the trailing edge of the wing. All right, good. So one point of flap means pressing F7 one time. If I wanted to retract the flaps, I would have to press F6 per point. All right. If I wanted to completely retract the flaps, I would press F5. If I pressed F5 only once, the aircraft would completely retract the flaps, and this is what we name a clean aircraft. An aircraft that has the landing gear up and no extended flaps is named a clean aircraft. If I wanted to completely deploy the flaps, I can also press F8. F8 means full flaps down. So, and that's what I just did. Let's see if you can see how they are deployed. Slowly, take some time. Good. You can see how they are being deployed, and this is something you can also take a look at here on the cockpit. This is the indicator showing you what is the extension of your flaps. So flaps of 40 degrees would mean full flaps. Flaps of 0 degrees would mean flaps totally up, and that's something we achieve pressing F5, as I just told you. All right, so I just pressed F5 to retract the flaps, and they are now being retracted. Each of these numbers indicates the degrees that the flaps are extended. We will later use a flap configuration of 5 degrees for the takeoff at Santander, and flaps 5 is this number here, so it would mean 1, 2, 3 points of flaps. Okay, so 3 points of flaps, meaning we have to press F7 3 times, would set flaps of 5 degrees. Good. I don't know if I'm going too fast, but well, these are things that you have to know for your simulation session. Good. So let's now focus a little bit on how to navigate laterally. I've told you about how to change your heading using heading select and by changing the heading. And I will now tell you about how you can navigate with respect to a VOR. If you press Shift 4, you will open this panel, which is the radio panel. And the most important numbers or the most important frequencies that we are going to monitor in the exercise are the VOR frequencies that we are going to use. Currently, since I am in the Palma area, I have decided to monitor the frequency of the VOR of Palma, which is 117.7. Right? If I wanted to change to another VOR, let's say, for example, the VOR of Menorca, which or the VOR of Pollença, which is another VOR placed on the north of the island of Palma, which has a frequency of 116.4. These are frequencies that you can read on the charts. That will go later through the exercise. How can I change that? Well, here viewer that you can place your mouse with the wide or the shadowed hand, and each of these is going to either change the numerals or the decimals. So 116.4, I can place it here on the right hand, changing the numerals, and I set 116, and then I move to the shadowed hand and move it to 116.4. This has selected a VOR frequency on the standby window, but it's not moved it to the active window. All right, so here on the navigation display I will be reading the different VOR indications of only the VOR number 1, which is this one. This one is for VOR number 2. This indication is going to show only VOR number 1 and is going to show only the active VOR number 1. How do I change from standby to active? By pressing this transfer button. All right, you've seen now that I've changed from the VOR of Palma to the POR of Pollença. All right, but before doing that, let me talk you through a little bit how the navigation display works. And for that, you'll have to be a little bit familiar with these buttons over here. This knob will guide you through the different options that the navigation display has. All right, there is the first one, which is APP, that we will only use for the ILS approach, as you will later see. Then we have the VOR, which is the one that we are currently using and the one that you will use mostly for your simulation. And then we have two others that we want to use in this practice, which are for area navigation, which is something a lot more advanced that we go through in the master, which are map and plan. All right, so for the exercise that we'll perform in this practice, just be aware that you can either select VOR or APP, which stands for ILS. And since we are going to use VOR, here we have the DME readings. Be aware that we have a couple of needles that I want you to move up. So go here to where it says VOR 1 ADF 1 and click on the right button of the mouse, and then you will here be reading the DME, the distance to the station that you've monitored on VOR number 1. So this is currently telling us that our distance to the station that we are receiving in the 117.7 frequency, which is the station of Palma, which is actually in that direction, the direction that this thin arrow, this thin green arrow is pointing towards, is 5.1 nautical miles. Okay, so this is the DME. We can do the same for VOR number 2. Actually, currently VOR number 2 has no VOR tuned in. We will select, for the sake of the tutorial, the frequency of Pollença, which is 116.4, as I said before. I will prepare it here, 116.4 in the standby equipment, and then I will switch it to active. And now here on the VOR, we can clearly see that Papa Oscar Sierra, which is the VOR of Pollensa, is 27.4 miles. In which direction? Well, we had before the thin green arrow. We now have another thicker arrow, which is this one, green also. This arrow points towards Papa Oscar Sierra, VOR number 2. All right, good. So we currently have two VORs tuned in: VOR number 1, which is Juliet Oscar Alpha, and VOR number 2, which is Papa Oscar Sierra. But this is just, please be aware that this is just providing us indications of where these stations are with respect to where we are now. This is by no means influencing or modifying the trajectory of our aircraft. We can just modify the trajectory of our aircraft by selecting the heading here, the lateral trajectory of the aircraft. So if I wanted to turn right and go towards Papa Oscar Sierra, or let's say I wanted to turn right, yes, let's say I wanted to turn left to go towards Papa Oscar Sierra, which would mean a track of about 030 degrees, as this thick green arrow is showing. Not only by introducing this Papa Oscar Sierra frequency on the VOR channels is the aircraft going to fly towards that station. I'm just monitoring, I'm just looking at where it is. I would have to change my heading here by the left to force the aircraft turn to the left and go towards wherever I want. All right, so if the station is on this track, which is about 025 degrees, I would select a heading similar to 025. Why do I say similar? Because once I am established, I will have to correct for the wind. So if I wanted to fly towards Papa Oscar Sierra, I would place the magenta knob coincident with the thick green arrow, which is the VOR number 2 arrow, a little bit more to the left, because since we are turning, we are moving, and it's still correcting. And then when I'm established, I will take a look at the wind, and I will correct 2, 3, 4, 5 degrees, enough so that the wind doesn't take me off my track. All right, good. So here on the navigation display, let's finish the turn. Good. So I make it coincident. Let's say 0 to 1 seems to be fine. All right, so the aircraft is currently flying with a magnetic heading, which is this indication that we have here, heading magnetic of 0 to 1, which is 0 to 1, which is the one that I told the aircraft to fly at. What's going to happen, since the wind is slightly coming from the left, the aircraft is going to drift to the east of our position. You can see here that this is the heading, but as I told you before, similarly to what we can read here with this white cross, here this white line crossed 3 times indicates which is the track of our aircraft, and the track is slightly to the right of our heading. So we will have to correct for the wind, not to make the heading coincident with the thick green arrow, but to make the track coincident with the thick green arrow. That means turning a little bit to the left, let's say 017, and this way I am putting this white cross inside. Maybe I did it too much. 018, 019. I'm correcting for the wind, and I am flying towards this Papa Oscar Sierra station. All right, if I wanted to fly towards Juliet Oscar Alpha, what would I have to do? Well, I would have to look for this other thin arrow, which always points towards the station tuned in VOR number 1. So that would mean turning left towards that station. Good. So this is very useful when we want to fly towards a station. All right, towards a VOR. We are not talking about NDVs in this exercise, but similarly, just so that you can have a look, I will show you how it's done. Let's look for an NDV station here in the vicinity of Palma. Let's let's look at this one. Papa Tango Charlie, it's in the frequency 401 kilohertz. So I would have to select here 401 if I wanted to know what's my position with respect to that navigate. 401 401, and then I would turn it active, and this is the ADF, the automatic direction finder that we've talked about in class. And then I would have to switch this DME or indication button needle from VOR1 to ADF1. How? By pressing with the left button of the mouse twice. And then now I can clearly be reading here that ADF1 is being plotted with a blue arrow instead of a green arrow, and it is to the tail of my position. So if I wanted to fly towards that NDB, I would have to turn 180 degrees, probably to the left, and try to go towards that station. All right. So this way, this is the needle of the ADF, this is of the automatic direction finder, that points towards the station that we have tuned in this box here. Good. But we are not going to care about NDBs that much in this exercise. We're going to care about VORs, and we are going to care about VOR navigation. I've so far told you how to navigate 2 stations, but we won't only have to do this. We will have to follow radials. We will have to follow outbound and inbound radials, and for that it's very important. I'm going to turn this back to VOR, and I'm going to navigate, since I am almost over Juliet Oscar Alpha, and it's very difficult to navigate with respect to a navigate when you are really close to the navigate. I'd rather switch to Poyensa, which is farther away. It's going to make things easier for us. So I will select Poyensa both in VOR number 1 and VOR number 2. And how do we navigate with respect to this VOR? Well, this arrow, as I've already said, points towards the station, but let's say I want to navigate on radial 225 of the VOR, proceeding inbound. By taking a look at this instrument, you have to be able to know what's your position, to be able to draw on a map what's your position with respect to the VOR. If the VOR is to the northeast of your position, as this arrow is showing, it's telling you that the VOR is on track 025 more or less. This is indicating that you are on the radial that is exactly the opposite, this one, which is 225 or 220. All right, so you are on radial 220, 30 miles out. All right, how do you change the radial? Well, this spade, this white spade, and this magenta bar is what we are going to use to navigate with respect to VORs in order to intercept and follow radials. Let's say, as I said, that I want to intercept radial 225. Where do I select the radial I want to intercept? Here, on this box that says course. All right, it could also say radial, let's say, although it's not exactly the same, because sometimes the course is 180, it's the opposite of the radial. But well, for the sake of this very first example, let's select here the radial that I've set, 225. Okay, so what is this indicating? Well, this instrument is indicating that the radial is to the west of our current position. All right, this magenta line is showing us that we are not on radial 225. We are already at another radial. Well, clearly here we can read on which radial we are at, because we've kept on flying eastbound, and we are currently on radial 190. If I selected here radial 190, well, what's happening? This magenta bar is centering into the white spade. So when we are on a radial, or when we are on the selected radial, what's going to happen? Or when we are approaching the radial, that the magenta bar is going to come into the white spade. As I said before, let's assume that I want to intercept and follow radial 225 proceeding inbound. Well, this is the reference I have to navigate with respect to, and I would have to turn left, but not to the station, because if I currently flew towards the station, I would never intercept and follow radial 225, because I'm currently on radial 180 almost. You can read it here. I would have to turn a lot more to the left, chasing for the magenta var. All right, so let's say 320, more or less. All right, so what's going to happen? Well, I'm about to cross the position of the navit, of the VOR. The VOR is currently just ahead of us, but if I continue straight ahead, I would not be flying on radial 225 inbound. I would be flying on radial 180 inbound, which is the radial at which I am currently on. So what's going to happen? As I keep on flying a little bit more towards the west, this needle is going to be moving to the right, because we are going to be leaving the VOR more and more to the right of our position. And as soon as we are on radial 225, which is the radial I've selected here, this magenta bar is going to come into the white spade, and I will have to turn right, looking for a track of 045, which is the opposite of 225, to fly towards the VOR. Maybe this is a little bit messy for you if it's the first time that you come up with these concepts, but these are things that we've already explained in class, and I've given you a website link in which you can practice these kind of things. I mean, you can play with the relative position of the aircraft with respect to the VOR, and how this changes the presentation on the VOR panel, etc., etc. All right. It's going to take some time, so I'm going to speed up the simulation. You can clearly see how we are leaving the VOR more to the right of our position. You can see how this this arrow is falling to the right, and radial 225 should be coming. We are crossing different radials. Let me show you on the map. So here is the Papa Oscar Sierra VOR, and radial 180 would be completely to the south, to the magnetic south of Papa Oscar Sierra. That's where we were, and we are flying on this track looking for the 225 radial, which should be something like this. And once over this radial, once we cut this radial, we will turn right towards the station. That's what we are going to do. I'm looking for radial 225, which is ahead of myself currently. Okay. And how will I know that that I am approaching the radial? Well, as soon as I see the magenta var coming into the white space, which is something that's going to happen very shortly. I'm going to go back to normal. Now you can see that slowly the magenta bar is coming into the white space. All right. So what am I going to do? If I don't want to miss the radar, I'm going to start turning right. And I'm going to start turning right. Initially with a heading of initially heading north. And as it keeps on coming, I'm going to continue my turn and intercept completely the radial. Good. So now I'm about to get established on radial 025. Once I'm on the radial, on radial 225 inbound, which means a track of 045 magnetic degrees. Be aware that what I have to do is not set a heading of 045, but set a heading such that the magnetic track is 045, and given this wind, this means a heading slightly lower than 045, so probably 042 should be enough. This way, currently, I am flying towards the VOR, which is 17.5 miles ahead of me. Be aware that since I am approaching the VOR, the DME readings are decreasing. I'm getting closer and closer to the station, and I have it centered at radial 225. All right, good. So I think that this should be enough for the navigation display explanation. And the only thing that I am missing, that I haven't explained yet very well, is the flight director. I will do it very briefly. As I told you before, I can disconnect the autopilot by pressing this button anytime, and I am now flying the aircraft manually. Good. So if I wanted to fly the aircraft manually, now I have true control of the aircraft. Be aware that these lights did not switch off. Why? Because, well, first of all, the aircraft is manipulating the engines by itself. All right. If I moved the throttle, which is something you cannot see, but if I tried to move them, the aircraft does not react because the auto throttle, which is the button, this button here, is engaged. If I disengaged it, now I have full control over the engines also. You can see how I am decreasing the thrust. All right. So now I have total manual control of all ailerons, rudder, elevator, and throttle. And the flight director is this button here that hides or displays a magenta cross that appears on the top of the primary flight display. How does this appear? Well, I have to switch the flight director to on, and now I can select whatever heading I want to fly. Let's say I want to fly on heading 090, and I want to descend down to flight level 100 at a speed of 210 knots. I connect again the auto throttle, but the autopilot is not forcing the aircraft to turn towards heading 090. It has to be me, and the flight director is indicating me what to do manually. Just by looking at this cross and trying to center this cross, I will achieve the values that I have selected here. So this is basically telling me to move the aircraft to the right, looking for the cross. So now I have it centered, and pitch the aircraft down. Why down? Looking for the speed of 210 knots that I have selected. So basically the autopilot, what the autopilot does is it just keeps this center crossed, and this center moves or changes according to the MCP values that the pilot introduces here. Good. So now as I am reaching 090, if I keep on turning, look at what's happening to the vertical part of the cross. It's telling me to turn left. That's what I have to do. So I just have to follow these indications. If I don't want to do it manually, I can just press the master button of the autopilot, and it will do it for me. You see, the autopilot always keeps the cross centered to perfection, looking for the values that I've introduced here. Good. So far so good. I think for the first part of the exercise, this is more than enough. And what I'm going to do now is that we're going to start with the second part of the exercise, which is the local Santander flight that I will perform. So you can see how this is done, and you can do it by yourselves at the simulator without having to stop too much. Good. I'm going to close all the software so that you can see how I open it, and know how to do this when at the lab. Good. So you will find a folder on the top right part of your desktop that is named 737 PMDG. You'll have to open it and open the Microsoft Flight Simulator. Good. And here My simulator is in German, but you will have to select here departure airport, which is Lima Echo X-ray Juliet, and runway 29, which is the runway from which you will be departing. And well, the aircraft that you want to fly, let's say there we go, and then you say start your flight, and we are placed on the head of runway 29 at Santander. Good. It should not appear like this in the three-dimensional view, but if it appeared like this, well, just click on the right hand side, cockpit, and say cockpit, and you will get the two-dimensional view. Good. We want to fly not with the standard atmosphere, because that would mean that we don't have to change from QNH to QNE, because pressure at sea level would be 1013, but with the real atmosphere of the day. And for that we have another program here in the inside the folder, which is named FS Real WX Pro. Please open it. All right, open it, download the weather, the real weather of the day, and transfer this weather to the simulator. It says weather transfer complete. So these are the conditions, the current conditions today at Santander. We are having wind slightly for runway 11, although we are going to continue using runway 29 because the whole exercise is prepared for runway 29. It says that it's CAVOC, ceiling and visibility okay, so there are no clouds, temperature is 24, dew point is 18, and QNH is 1026. The most important part here being the temperature for the ISA deviation and the QNH 1026. All right, so going back to the simulator, we will prepare this now for the exercise. Good. I'm going to go through this reading of the statement just to make sure that I don't miss any of the things that you have to do. So it says, description of the mission. We will depart from Santander, runway 29, using the Bilbao 3 Romeo departure up to flight level 100. What is the Bilbao 3 Romeo departure? Well, here by the end of the statement you have the different charts, and this chart that says this one that says Carta de Salida Normalizada plots all the different departures that are designed from runway 29. We will use the one named Bravo Lima Victor 3 Romeo, which is this one. I'm going to rotate this view. Bravo Lima Victor 3 Romeo. It's this one. We go over the VOR of Sierra November Romeo, and then we turn right on heading 125. We intercept and follow radial 072 of Sierra November Romeo, all the way down to the 17.6 DME from Sierra November Romeo, and then we change our reference. Instead of flying with respect to Santander, we change and we start flying with respect to Bilbao and go to the VOR of Bilbao. The description of this standard departure is given in the next page here, where you can read runway 29, which is the runway we're going to use, Bilbao 3 Romeo. Climb direct to the VOR DME of Sierra November Romeo, turn right with a maximum indicated airspeed of 215 knots, climb to magnetic heading of 125 degrees, and then intercept and follow radial 072 of Santander. It should say outbound to 17.6 DME of Sierra November Romeo. And then, once over that point, turn right to intercept and follow radial 302 of Bravo Lima Victor. It should say inbound, direct to Cutter, and then direct to the VOR of Bravo Lima Victor. And this is the minimum required gradient to avoid any obstacles that with this aircraft and today's atmospheric conditions and weights we are going to completely achieve, so it's not going to be a problem. But in part of the assignment that you have of this practice, you have to plot the minimum climb gradient required for each part of the mission and whether or not you have achieved vertically this minimum required gradient. Good. So Let's go back to the simulator and I'll start reading the description of the mission. It says that we'll depart from runway 29 using the Bilbao 3 Romeo departure up to flight level 100. So I will select here flight level 100 like this. It says that then later, once over Bravo Lima Victor, we will maintain our heading. Basically, let's go back to the chart so I can explain it to you here. Once over Bravo Lima Victor, we will maintain our heading for 1 minute, for 60 seconds. Then we will turn left all the way back to the VOR. So this is named a water drop maneuver, in Spanish, gota. A water drop maneuver, and then once we are again on Bravo Lima Victor, we will perform our standard arrival. And it is then when we will start our descent. We will overfly Bravo Lima Victor for the second time at flight level 100, and then we will start the Bravo Lima Victor 3 Echo arrival for runway 29, which comes determined here. Okay, we will vacate Bravo Lima Victor using the 270 radial outbound, descending to a minimum altitude that comes determined by this chart and that we can read here, which is 6,000 feet for this leg. We will then have to switch from QNE to QNH because we will descend through the transition layer. And 17 miles outbound from Bravo Lima Victor, we will be at Nurbi. Okay, this is point Nurbi. Be aware that Nurbi has these coordinates and is defined as the intersection of radial 270 from Bravo Lima Victor and radial 112 of Santander. How can I move myself here? Okay, like this. So this is radial 112 of Santander. So Nurbi is at radial 112 of Sierra November Romeo, 27.3 miles out, or equivalently on radial 270 of Bravo Lima Victor, 17 miles out. Once over Nurbi, we will have to turn right, following radial 112 of Sierra November Romeo inbound, and then descending from 6,000, which was the minimum altitude at Nurbi, down to 5,000, which is going to be the minimum altitude at Ampur, which is this point here. Ampur is placed on radial 112, same radial, but 22 miles instead of 27.3 miles. So the distance, this distance between this point and this point is a little bit more than 5 miles. And then we'll descend to 5,000 feet. And Ampur is defined here as the IAF. IAF stands for Initial Approach Fix. And it is at the IAF that we will start our approach maneuver. Initially, we will perform a VOR approach, which comes determined by this chart here. How do I know that this is the VOR approach? Well, because clearly here it says Carta de Aproximación por Instrumentos, Santander VOR approach for runway 29. All right, and it starts at Ampur, the point that was the last point of the Bilbao 3 Echo standard arrival of the previous chart. All right, so here what this chart is indicating what we are going to do, and we'll go through the exercise later. Basically, laterally we will have to continue on radial 117 towards the VOR, and vertically we will have to comply with this procedure. All right, being the minimums, the ones that that we can read on this chart. In this case, 1,800 feet of altitude, very high minimums. Why? Because this is a non-precision approach, because it has no vertical guidance. Be aware that VORs only provide lateral guidance, and so vertically we'll have to perform this chart without the assistance of any radioelectric navigate, not like what we'll do later, which is an ILS approach. So we will continue this approach all the way down to the point named MAPT, which is the missed approach point. We won't be able to go below 1,800 feet if we don't see the runway, which will be the case. We will not see the runway, and then we will perform a missed approach. All right, and then we will perform a missed approach, maintaining runway heading all the way to the VOR, and then performing a water drop here, and ending up at the VOR of Sierra November Romeo. And it is from that VOR of Sierra November Romeo that we will start a second approach, which in this case is going to be not a VOR but an ILS approach. Now we are going to have vertical guidance for the approach, and we will perform this chart. We will perform this outbound leg, and then we will turn right and intercept the localizer and the glide slope. But this is something that you will much better see as we go through the exercise. Good. So it says one of you is going to be the pilot flying PF, while the other one is going to be the pilot not flying PNF. The role of the pilot flying is to constantly check and monitor the flight displays, as well as use the keyboard or the joystick for takeoff and the mouse for autopilot selection. The pilot not flying must check the navigation charts together with the pilot flying and help him with whatever he needs. In real life, he would also be in charge of communications with air traffic control. During the exercise, the pilot not flying is in charge of writing down all the required flight values. Good. It says place your aircraft at Santander runway 29. El Mundo irá al aeropuerto. Here it's Umwelt und Flughafenauswahl that I've already done. Connect the FS Real WX, which is this weather program that transfers real weather values to the simulator. And then what we're going to do is, since today's visibility is very good and we don't want that to be for our practice, because I have said that we will reach the minimums and we want to see the runway, and it is because of that that we will perform the missed approach procedure of the VOR chart, we are going to deteriorate the visibility of the simulator. And how do we do that? Well, I click on El Mundo, Meteorología, and then here I click on Personalizar, and I reduced the visibility to a value of 1 nautical mile. Alright, so 1 nautical mile, then I click OK, OK, and then you can see that it's very foggy. Once I've done that, please remember, very important, to close once you've written this down and you already know the temperature and the QNH, close this program, because otherwise it's going to update weather conditions and it's going to increase the visibility again. So the only way we can avoid that is by closing that refreshment. Good. So before doing anything else, it says we have to configure our aircraft. It says before doing anything else, open your FMC, your flight management computer, by pressing Shift 3. By pressing Shift 3, I open the flight management computer, which is this thing that popped up here, and it says we have to go to Setup, Aircraft, Displays, and go to the page 9 out of 9. We can change, we are on page 1 out of 9. We can change that by pressing here Next Page or Previous Page. So we go to 9 out of 9. And then make sure that the weight units we are using are kilos and not pounds. Alright, you can change that by pressing on this button here. So make sure they are kilos and not pounds. Last year a student did not change it and ran out of fuel in the middle of the simulator. So please make sure you are using the right units. Good. Then we return to menu. It says here menu, FS Actions, Payload. And now we are going to select the weight of our aircraft. You can do that by yourselves, whatever you want. You can select the number of passengers for first class, the number of passengers for coach class, and then the amount of cargo for the forward and for the aft bulks. Alright, you can also here press on Set Random, and the simulator will select whatever values they want. Alright. The important thing here is that it gives you a zero fuel weight, which is the sum of the operating empty weight and the payload that you have. And that zero fuel weight plus the amount of fuel that you've got on board is going to give you the actual mass of the aircraft, which is the gross weight. The units here are metric tons. Alright, so I'm currently having 55,200 kilos of weight of mass in the aircraft, plus all this fuel, which adds up, or more than 20,000 kilos of fuel adds up to more than 75,000 kilos. Good. This indicates the position of the center of gravity. If you put too much weight and balance, let's imagine I put on the forward cargo a lot of weight, what's going to happen? Well, the center of gravity is going to move forward towards the nose, and if you unbalance the aircraft, this would appear yellow, indicating that you should change your distribution of masses. All right, I suggest that you just click on set random. Well, I've just clicked on set random, and it's indicating that I am overweight with this amount of fuel, which is not going to be a problem because I will later empty the central tank and decrease the amount of fuel that I have on my lateral tanks. So this is not going to be a problem. I would be more concerned if your zero fuel weight distribution of masses did not fall within the tolerance of the 737. Good. So you have to write down these values for your report, and I'm going to change the amount of fuel that I have on board. I go to menu, FS Actions, Fuel, and as I said before, here on this screen, you can read the indications of fuel that you have on your aircraft, and it's indicating that the central tank is totally full. I'm going to select 0 kilos of fuel for the center tank, so I press on 0 and then I introduce that value here. It clearly shows that I've removed all the fuel that there was in that tank, and for our mission today we only need 2500 kilos of fuel per tank, so I select 2500 for tank 1 and 2500 for tank 2. Alright, you can read them here. Don't worry if these numbers starts decreasing. It's normal because we have the engines running. So if the engines are running, they are obviously using fuel, and they are the amount of fuel we have on board is going to decrease. This should not be a problem if you do things in time. Okay, so don't try to pause the simulation or do anything because you are losing fuel, because it should be more than enough for the practice. Okay, so just don't worry anymore about the flight management computer. Good. Now you can close that by pressing Shift 3 again, and let's forget about the FMC. And our statement says that for proper vertical navigation, we need to select properly the QNH. All right. So you can read that from the meta. Remember that for this exercise that I am doing here in the simulator, the QNH was 1022. So I select here in the Colsman window 1022, and you can read that here. So the altimeter should be reading the actual elevation of the head of runway 29 at Santander, which is 280 feet, which is fine. Okay, good. And then I'm asking you to compute the deviation of the standard atmosphere in Celsius degrees. Assume that we are at sea level, so we were supposed to be here at 15 Celsius degrees, and the mirror, I think, it said we were at 24 Celsius degrees. So the ISA deviation today here in Santander is +9. All right. The transition altitude comes determined in the standard departure chart. Here in the SID chart, you can read TA 6000. All right, TA 6000. That's the transition altitude, and it is always the same one for this airport. So the transition altitude is going to be 6000. That means that we're going to climb using the QNH up to 6000, and when at the transition altitude, we're going to change from QNH to QNE. All right, and after we are established at flight level 100, and when we are starting our descent back to the airport, we will have to again be aware of what's the QNH at Santander, because we'll have to know our altitudes with respect to sea level in the area of Santander, and then we'll have to change again from QNE to QNH at the transition level. And the transition level, remember, that is a function of the QNH. We need to calculate a transition level that ensures a minimum width of the transition layer of 1000 feet. So assuming a decay of 1 millibar of pressure every 30 feet in the atmosphere, you have to calculate what's the transition level. All right. today's transition level is 70 because the QNH is 1022. Alright? I won't enter into details because this is something we've supposedly seen in class on the blackboard, and you should have done some exercises. So please be aware that when you come to the lab, you are able to compute the transition level given the value of the QNH and assuming a decay of 1 millibar every 30 feet. Good. So we'll now prepare the aircraft for departure, and it says, the statement says that we have to comply with the before takeoff checklist procedure. The before takeoff checklist procedure is table number 3, and it says QNH set 1022, it's fine. Flight director on, there we go. Auto throttle on, there we have. Indicated airspeed, max selector, and 165 knots, so I will select 165 knots here. Flaps, it says 5 degrees, that means 3 points of flaps, and that means pressing F7 3 times, so 1, 2, and 3. And now we'll just wait until I see this established at this position of flaps 5 degrees. Auto brakes to RDO. These are the auto brakes. I won't enter into too much detail with this, but I have to select it to RDO, which basically stands for rejected takeoff. It's basically an automatic way of stopping the aircraft if we reject our takeoff. If for any reasons, let's assume there is a dog on the runway or I have an engine failure and I want to cancel my takeoff in the middle of my takeoff run, I could just pull the throttle backwards, and if I have the auto brakes selected to RDO, that will make the aircraft automatically apply brakes to the wheels and stop the aircraft on the runway, hopefully. So next line says Navates shift 4 prepared for the standard departure, and this is where the navigation thing starts happening. So the standard departure says that we have to continue on runway heading up to the VOR, and then once over the VOR, turn right on heading 125. The VOR is not at the airport, it's a little bit apart from the airport, but it's clear that the frequency of this VOR is of extreme importance for the exercise, and the frequency comes determined by the chart, and it's 115.3. So I go here to the radio panel and select 115.3 in VOR number 1. Alright, and I say transfer and put it into active, and then I change this from VOR from off to VOR number 1, so I can clearly read here the distance to the navigate, and I will move this knob to VOR. Alright, this is not exactly the presentation that we had before. In order to do that, you have to click here with a finger and open up a rows of 360 degrees, which is more convenient for the practice. Otherwise, with this other one, you're getting like a zoomed in plot that you won't be so familiar with. So open it up to 360 degrees. Don't go too far away and get this FIS mode nav frequency disagree, because that means that you are trying to monitor an ILS while you've tuned in a VOR. So you have to be coherent. If here you've introduced a VOR frequency, here you have to be selecting a VOR display, and the other way around. If here we're introducing an ILS frequency, as we'll do by the end of the practice, here you should be selecting the APP mode. Good. So we're going to continue on runway heading. If I want the aircraft to continue on runway heading, what's that heading? Well, I'm currently on heading 292. So I'm going to select a heading of 292, which is what I want the aircraft to do just after the departure. Be aware that I'm already receiving the signal from Sierra November Romeo. It's telling me that it's 4.5 miles ahead of me, and this thin green arrow, it's pointing towards the station. So it's just ahead of the runway, which makes sense with this picture here. The VOR is just ahead of the runway. Good. So I'll continue all the way up to the VOR, climbing up to flight level 100. When passing the transition altitude, I will change from QNH to QNE. And once over the VOR, which is something I realized because this arrow will stop pointing in this direction and will rotate and indicate that the VOR is to the tail of my position, not to the nose of my position. That will mean that I am over the VOR. Another way to see it is that the number of miles to the station will stop decreasing and will start increasing. That means that I have overflown the station. Then, according to the procedure, I'll have to turn right on heading 125, which is something I'll do. What for? Well, to intercept and follow radial 072 outbounds. So the first radial I'm concerned about is radial 072, and I will select here radial 072. Good. And since I don't have the master autopilot button connected, I can already click here on heading select and level change. That's not a problem at all. And make sure that this appears here on the top of the primary flight display. And the flight director magenta cross has appeared. Good. So I continue with the checklist. We were on the navaids row. Course and heading selectors are according to the SID. Yes, they are. So course is 072 and the heading is the runway heading all the way up to flight level 100. Level change on green, selected cleared altitude, flight level 100, and it says transponder, code entered, and TARA. How do I do that? Well, I click on Shift 4 and here I have a transponder code. Remember that this is something that we've seen in our surveillance chapter. This is the code assigned by the air traffic control so that they can see the AS on their screens. Let's assume that the air traffic controller gave us 4303 as the code. And we select this, which is the TCAS, to TARA, Traffic Advisory Resolution Advisory. Well, this is just in case we met other aircraft to have the TCAS active. Good. And now it says FS recorder start recording. This is very important, especially for the report. Don't forget to do this because this is what's going to give you the file for you to treat it later at home. So click on FS recorder and then record. This menu will pop up and click on OK. And here on the bottom left, in the bottom right corner, you will read recording. This means that the simulation is about to start and you're already recording what you're going to do. Good. So we've gone through our checklist, and once we are ready for the departure, what we're going to do is that I'm going to apply thrust. I can do that with the joystick. You can see that there is an outer ring here in the N1 indication. That means that I am applying some thrust. Or also what I can do is I can press this screw button, which is obviously some kind of makeup or invention for the simulator to help the users. I can click on here and it will apply takeoff thrust. I will continue straight ahead until I reach an indicator speed of 145 knots. And when I reach 145 knots, I will pitch the aircraft up and select a seat angle of about 15 degrees. Not more than that, otherwise you can stall the aircraft and fall down. As soon as I have positive variometer indication, I will put the gear up, and little by little, and as soon as possible, I will select the autopilot. I will connect the autopilot. You cannot connect the autopilot below 400 feet above ground level. All right? Just to let you know. And I will keep on the navigation, maintain runway heading to the VOR. So that's what I'm going to do now. Good, I've completed the before takeoff checklist procedure, and then now I apply full thrust for takeoff. You can see here how the engines are running. I am accelerating, and there we go. The anemometer is alive, 60 knots now, accelerating quite well. 100 knots. And now when I reach 145, I'll start pulling up the aircraft. So 145, there we go. I start pulling the aircraft up slowly, smoothly, not more than 15 degrees of seat angle. So variometer is indicating positive reading, gear up. I press letter G on the keyboard, and I keep on flying at 165 knots more or less. As soon as I can, I connect the autopilot. That's all I had to do. So now the autopilot is going to be in charge of centering the cross. And I keep on navigating towards the VOR, which is what I have to do. I have to continue navigating according to my standard departure. I can start accelerating the aircraft to 210 knots. What's this going to do? As I told you before, with the level change option on and full thrust, it's going to pitch down the aircraft to look for this speed. All right. At 175 knots, I can clean one point of flaps, so flaps 2, by pressing F6. Look, I am approaching the VOR. I'm only 1 mile apart, and the arrow is going to fall to my right and start pointing to the tail. And now at 210 knots, completely flaps up, I press F5. F5, so now I've overflown the VOR, and according to the chart, I have to turn right on heading 125. Good. So now I select 125 here. Please do this slowly, because if I did it too fast, the aircraft might fly, instead of by the right, by the left. Here, the aircraft is going to try to find this magenta knob by the shortest possible way. So if I turn this very, very fast, the aircraft is going to try to find it by the left instead of by the right. So be very careful with that. Many students have made this turn wrong in the past. Now, 6,000 feet, just passing, that's the transition altitude. So I change from QNH to QNA. I click here on standard. Good. If I didn't do that, I would not be flying later at flight level 100. I would be flying at 10,000 feet of altitude, which is different because the reference is different. Good. So I'm finishing my turn. Be aware that I can see nothing from outside. I'm relying completely on my instruments. Good. So I'll continue. It's turning to 125. And according to the chart, I'm going to continue on this heading until I intercept the radial. How will I know that I have intercepted or that I am on radial 072? Very easy. As soon as the magenta bar comes into the white spade. All right? Good. Since we are really close to the VOR, just 3 miles, everything is very sensitive. All instrumentations. I'm crossing many radials in a very short period of time. So I will have to anticipate. Be aware that when this indicates that the VOR is here, that will mean that I am on the radial. When the VOR is at position 252 degrees of where I am, that means that I am on radial 072. So I'll start turning left now to anticipate before, and there we see maybe I overshoot a little bit. I'm going to overshoot a little bit. There we go. So I'm currently on the radial and trying to intercept and follow this radial outbound. Looks like we have no wind today. This is not very normal. You may have some wind in your simulator the day you go. Good. So I'm already established at flight level 100. And I can now go through table 4. It says after takeoff checklist, autopilot on, gear is up, flaps up, level change and heading select engaged. Well, I'm already at altitude hold because I've already reached flight level 100. Good. So I'm going to try to center a little bit the radial into radial 072, a little bit more to the left. Let's see if it comes into, and auto brake off. Good, so it's coming into. Good. How long do I have to continue on this heading? Well, according to the chart, I have to continue on this track until I reach the mile 17.6. Good. Here I am on 072. And I'm going to start preparing for the next maneuver. When I'm on DME 17.6, I will have to change from navigating with respect to this VOR to navigating with respect to this other VOR, Bilbao VOR, which is on frequency 115.9. I'm going to put that into VOR number 2, 115.9, and put it active and prepare it in the standby of VOR number 1. Be aware that the indication that I am getting here is always of VOR number 1. Good. Now I can accelerate. We're going to make the exercise at 250 knots. Good. I'm only 4 miles from the point that I have selected, that is indicated from this point. And at this point I will continue turning right. On which track? I will look for a track of 302. No, this 302 degrees is outbound from Bilbao. The opposite one should be towards Bilbao. Okay, if this is the north, then this direction is clearly 122, the opposite of 302. So I will have to turn right, looking for 122 degrees. So 15, we're approaching the point. So as soon as I reach the point, I will start the turn immediately to avoid any possible overshooting. 16.1, 16.2. Okay, there we go. Then I start turning right on heading 122. Make sure that the aircraft starts turning. Good. And now I change my navigation reference from Santander to Bravo Lima Victor, and I change the course to 302. Or actually I could select the opposite one, 122, but well, for the sake of simplicity I will select 302, which is the radial I am following, although in this time with respect to Bravo Lima Victor, not outbound but inbound. Look, the radial is a little bit to the south of my position, so I will continue turning a little bit more to the south, 130, to intercept and follow this radial. And on VOR number 2, I'm going to, this was not switched on, I will put it DME, I will put Santander, yes, so I can have both references to both DMEs. Good. So I have here the number of miles to Bravo Lima Victor, and here the number of miles to Sierra November Romeo. And remember, the thin green arrow towards VOR number 1, and the thick green arrow towards VOR number 2. Good. So now I'm on the radial, 122. I'm a little sad that today's weather is so simple because I have no wind. Be aware that if I had some wind, I would have to be constantly correcting for the drift. All right. Good. So what am I going to do? I'm going to continue to Bravo Lima Victor, and then once over Bravo Lima Victor, I'm going to overfly the VOR, maintaining the heading, and continue for 60 seconds. Okay. I'm going to speed up the simulation a little bit. Don't do this when at the lab, because you are not that familiar with the simulator, and you may ruin your simulation. So be patient. Good. Remember, when I get to Bravo Lima Victor, I will continue for 60 seconds. Here I have a chronometer that I will start. I can start the chronometer by pressing on the top left corner of the chronometer here with a finger, and this needle will stop moving. This way I can count for 60 seconds, and then once I am done with the 60 seconds, I will turn by the left towards the VOR of Bravo Lima Victor. How will I know where the Bravo Lima Victor VOR is? Well, by looking at the thin arrow. Good. I am only 5 miles apart from Bravo Lima Victor. Be aware that the DME indication never gets to 0. I've already explained this in class. The DME indication gets to the altitude with which you are with respect to the DME station. All right? Because it does not measure the lateral distance, it measures the true distance between the DME station and the aircraft. Okay, so it won't get any lower than maybe 3 miles, well, 10,000 feet, yes, something like that. 2 miles probably. Good. So once I am over the station, well, the radial is a little bit to the north of where I am, but not too much. 119. As soon as I see the arrow turning to the tail of my position, meaning I am over the VOR, which is something that is about to happen, I will start the chronometer. Good, so now I've lost the signal of the VOR. This means that I am over the VOR, and now I start the chronometer. And this starts counting, and I will continue for 60 seconds. And once I am done with this, I will turn left towards the station. Let's take a look at the standard arrival chart. So I'm continuing 60 seconds, and then I'll turn left, and then I will overfly the VOR again. And once I overfly the VOR for the second time, I will start descending down to 6,000 feet and preparing the approach. And vacating on radial 270. So I'm going to prepare the radial. Since I don't care anymore about radial 302, I will prepare now radial 270. Good. So 45 seconds now. I'm about to reach 1 minute, and there we go, 1 minute. So I'm going to turn by the left. Be careful, do not turn by the right. Turn by the left, you can see it here, all the way to the VOR. So I make the magenta knob match the thin arrow that points towards VOR number 1, which in this case is Bravo Lima Victor. Good. Now it's very important for the approach that you don't start the approach with too much energy. Many students end up being too high and too fast. Please be aware that you have to control your energy very well. That's why I'm going to start reducing now my speed to, well, not now, but when I finish my turn, because if I change my speed now, this may change the turning radius, which is something that you have to come up with in your assignment. But as soon as I am established again on my track towards Bravo Lima Victor, I will start reducing to 210 knots. Okay, be aware that as I keep on flying, the VOR keeps falling more and more to the left of my position, so I have to be constantly correcting until I finish my turn. Good, so I'm about to finish my turn. Then currently ahead of myself is Sierra November Romeo VOR, but I don't have to go there. I have to go to Bravo Lima Victor, which is here. Good. Good. So now that I have finished my turn, I will reduce to 210 knots. And once I overfly Bravo Lima Victor, I will intercept and follow radial 270 outbound and descend down to 6,000 feet. I can already prepare this for 6,000, even though be aware that I can change here the selected altitude, but the aircraft does not descend until I press level change. So I prepare here 6,000, and as soon as I am over the VOR, I start the descent. The VOR is a little bit to the left. I'm almost over the VOR. I will again lose the signal and recover it later. As soon as I lose the signal, I will turn a little bit to the right, because otherwise the radial will end up, when I recover the signal, to the north of my position. Okay, so the needle is dancing, meaning that I am very close to the VOR. I've just lost the signal, so I am going to turn right on heading 270, and there you see I've just recovered the signal. I've overflown the VOR. I'm going to start the descent down to 6,000 with the level change option, so it's going to apply idle thrust and start pitching down looking for 6,000. If I am already going for an altitude, that means that I am going to penetrate the transition layer. I can already change from QNE to QNH, so I change from standard again to 1022. It's very important that you have the right vertical reference, otherwise you may end up against a mountain because of not complying with the proper vertical restrictions. Okay, so the radial is still a little bit to the north of my position. I will try to intercept it by flying a little bit more to the north, and I'm going to prepare my aircraft for the conditions that have to be acquired at the IAF at the initial approach fix, which is Ampur. All right, and that's given by the IAF checklist on table 5 of the statement, and it says indicated airspeed 210, already selected, altimeter already QNH 1022, flaps 5. I'm going to press F7 3 times, 1, 2, 3. Navigate frequencies, well, I will have to change them because once over Nurbi, I will have to change from flying with respect to Bilbao to flying with respect to Santander again. I will do that later. And then it says auto brake 2 or 3 and minima selected from the chart. I will do that later. Good. So what the VOR, sorry, the radial, we just passed the radial a little bit. I should not have changed the window. Good. So we are 8 miles away. Be aware that Nurbi, as I told you, is 17 miles away. So we are somewhere in between Bravo Lima Victor and Nurbi here, down to 6,000. You see, it takes a lot of time for the aircraft to descend, so you have to anticipate a lot in terms of controlling the energy of your aircraft. Otherwise, you're going to make a very high and very fast approach. And that can end up normally with a missed approach or a runway excursion. Good, so I am intercepting the radial. Okay, 10 miles out. Reaching 1,000, well, reaching 6,000 almost, 7,200. That's a little bit to the south. There we go. So once over Nurbi, or a little bit before Nurbi, not to avoid any kind of overshooting, I will change and start flying with respect to Sierra November Romeo, which is already in the standby frequency. I will change the course from 270 radial of Bravo Lima Victor to radial 112 of Sierra November Romeo. The only thing is that instead of flying outbound with respect to Sierra November Romeo, I will be flying inbound Sierra November Romeo, meaning that my track should not be 112 degrees but 292 degrees. Good. Reaching 6,000, centered on the radial, 14 miles. So I'm about to reach Nurbi, which is, remember, in DME 17. I am reaching DME 15 now. At about 16 DME, I will start anticipating the turn to avoid overshooting of radial 112 of Sierra November Romeo. Good, so I'm 16 miles now. I will start turning right, heading 292, looking for that track. And here I'm going to select 112 radial, but not with respect to Bilbao, but with respect to Santander. Good, and now I'm here getting Santander as VOR number 1, and laterally I have to be on this radial. Vertically, the start procedure says that I can descend now to 5,000, so I select 5,000, level change. Good. And now I'm going to pass to the VOR chart, which is this one. All right. All right. So I will reach Ampur when I am 22 miles from Sierra November Romeo, so almost now at Ampur. And from Ampur at 5,000, I will have to descend down to 4,100 at 19 DME from Sierra November Romeo. All right, always on radial 112 of Sierra November Romeo. I can be preparing the minima, which is a decision altitude of 1800. I can already be doing that. Here I say Baro, and then I select 1800. Okay, so now I'm 21 miles out. I can go all the way down to 4,100 according to the procedure, and that's named the IF, intermediate fix. And if you go through the statement, there is another checklist for the intermediate fix that says that the speed has to be 180 degrees and flaps 15. So 180 and 2 more points of flaps. Since I am deploying flaps, the aircraft, it takes a little bit of time for the aircraft to decrease the speed and keep on descending, so you may end up a little bit high. Now I am at the IF, it's 19 miles, so I will continue with the chart. It says that now I can continue down to 3,200, so 3,200, until 13 miles out. All right, and once at 13 miles out, I will have to continue using this chart, meaning that for a speed that I will have of about 140 knots, I will have to descend at a rate of about 900 feet per minute, more or less, giving me a slope of 3.5 degrees, down to 1,800. All right, good. So I can now continue decreasing my speed to 140. 145 says the checklist, gear down, flaps down, F8, and good. So I haven't reached yet 11 DME from Sierra November Romeo. Remember, I was still missing the Varo, the minima selection. So I will select 1,800. It's a very high minima, that's why it's taking me so long to select it. You can read it on the primary flight display, how I'm changing it. It's going through 1,700, and I'm about to reach, good. So now I've reached 1,800. Good. Laterally, I'm on the radial, I'm reaching 3,200, gear is down, flaps are down, prepared for landing, and 145 knots. Good. So I'm following the chart. I'm somewhere around here. So the FAF is 13 miles out. I'm already currently reaching the FAF. So I will go down to 1,800 at a rate, as I've seen on the chart, of negative 900 feet per minute. All right, just I'll show it again here on this chart that refers to this leg here with a ground speed of 140 knots, which is similar to what I am doing now, 152. I have to make a vertical speed of about 900, 1,000 feet per minute. All right, this is all the way down to our minima. Remember that we cannot descend below our minima if we don't see a runway. And since I have deteriorated on purpose the meteorological conditions of the exercise, we won't see the runway. How will we perform the missed approach? Well, we will climb all the way up to 4,000 feet and maintain runway heading to the VOR of Santander. All right. No, sorry, we won't climb up to 4,000. We will climb up to 6,000, which is what the chart says. The procedure of the go around is explained here. But if you comply with this procedure exactly, you will start the turn too early, so do what I say. Maintain runway heading until after the VOR, and then we'll make a water dog maneuver and start the ILS. Okay, so we're about to reach 1,800. We can't see the runway. I'm looking outside here. I can see some mountains, but I cannot see the runway. We are still 8 miles from, not from the airport, not from the threshold. Remember, this is from the VOR, and the VOR is 4.5 miles ahead of the threshold. So I am currently 4 miles, or a little bit less than 4 miles from the runway's threshold. Let's maintain the minima. You see how this flashed, as I told you before, from green to yellow, indicating that we cannot get any lower than that if we can't see the runway. And well, let's see. The missed approach point is defined here at 4.5 DME from Sierra November Romeo. So 7.2, 7.1. Looks like we won't make it. I'm going to start preparing the aircraft for the go-around, selecting an altitude of 6,000. Remember that this does not mean that the aircraft climbs until I click on level change. All right, so as soon as I make the decision, I will maintain heading selection, level change. I will increase the speed to 165 knots and select flaps 5 and gear up. All right, good. So 5.6. We're approaching the missed approach point. We can't see the runway. It's all very foggy out here. Very poor conditions. Okay, 4.8, 4.7. So the captain would say, okay, so go around flaps, and then I click on level change all the way up to 6,000, gear up, and flaps F5 and then F7 3 times to set flaps 5. You can see how the aircraft is climbing, maintaining runway heading, and I'm going to select the speed of 180 knots. Good. So we could not see the runway. We're currently overflying the runway, and we are going towards the VOR. Good, so the gear is up, flaps are set at 5. I think this is fine. What are we going to do now? We're going to overfly the VOR, maintain the track again for 1 minute, same way we did before, and then turn by the right on a water dog maneuver to the VOR. And then from the VOR on, we will continue with the ILS chart. I will show you how now. Good. So still approaching towards the VOR. I'm going to prepare the chronometer. I've just reset the chronometer. Okay, I'm about to reach 6,000. Since I'm going to maintain 6,000, I will continue flying with respect to QNH, because I will not penetrate the transition layer flying higher than that. Okay, I'm just now over the VOR. I start the chronometer. We'll continue on this heading for 1 minute. And then we'll turn right. So we are going to start the next chart, which is this one, the ILS, very similar to the VOR, but do not mistake it for the other chart, because this one has vertical, not only lateral, but also vertical electromagnetic guidance. All right, so I will start this chart from here. We will vacate it outbound following which radial? It says here alejamiento ver tabla, and we go to this tabla and it says tabla de alejamiento. Depending on our speed is going to be of 185 knots. We'll have to vacate the VOR on radial 104. So I'm going to be preparing that already here. Radial 104. 50 seconds now. And I said 185 knots. Okay, so 1 minute, there we go, and now I turn by the right towards the VOR. Good. So I'm going to continue towards the VOR, and from the VOR I will backgate it outbound using that table. And vertically, what will I do? Well, from the VOR at 6,000 I will descend after the VOR down to 4,100 until 19 DME from Sierra November Romeo. And here it's when I will turn right to intercept and follow the localizer, descending to 3,250 feet, and then I will first intercept the localizer, and then later, when 14.2 DME from Sierra November Romeo or 9.7 from the threshold of the ILS, I will intercept the glide slope all the way down. All right? Good. So let's keep on turning right towards the VOR. Still 5 miles away, to intercept and follow the radial. I'm going to start preparing the frequency of the ILS. The ILS frequency comes determined here on the ILS chart, and it says localizer 110.9. So I go all the way here and select and prepare 110.9, but still do not put it active because I am flying with respect to Santander VOR and not with respect to the ILS yet. Good. The VOR is a little bit to the right, but I'm fine this way. I'm fine this way, so I'm getting closer to the VOR. Okay, we're about to overfly a little bit parallel, a little bit to the northeast of the VOR like this, but that's fine. There are no mountains, there's just the sea, and this way we are going to make a smoother turn to the left. Okay, so now we are overflying the VOR. It's just a beam to our right, and we are going to start turning left, anticipating our turn to intercept and follow radial 104 outbound, and start our descent down to 4,100. So 4,100 level change, and well, I just overshoot the radial again. It's very, very sensitive. Good. What about the speed? Let's maintain 185 until we are established on the localizer, and then we'll reduce to 145. Good, so the radial is coming here. And we have to continue on this radial. Why is it turning more? It shouldn't turn more. Okay, I'm going to disconnect and connect heading select again. Another, if something like, if the simulator makes that crazy stuff to you during the lab, try to do that. Disconnect and connect again the heading selector. I've clearly missed the radial because of that mistake, but just slightly. Let's recover it again. Good. So as I just said, we'll go all the way outbound until 19 DME out, and then we'll turn right to intercept and follow the localizer. This turn could be of by the right towards heading west, should be fine to intercept and follow the localizer. The localizer has a magnetic track of 292 degrees that I will select on the course. Good. And now I'm going to prepare, I'm going to prepare for the minimums. The minimums now are not again 1800. This is a much more precise approach and are of 367 feet. So I'm going to prepare the minimums, VARO, and here I'm going to reduce them to 367. Let's hope we can now make it. We can now descend a lot lower, so probably we'll be able to see the runway. Here it goes. So VARO 367 feet. We are now on the radial 104. Still 8 miles out. Okay, so still 12 miles out. This is a little bit long. Still have to make it to the 19 out. I'm going to leave on the second VOR the reference of Sierra November Romeo, because here on this chart all the references are given with respect to both stations, the ILS and Sierra November Romeo, with a difference of 4.5 miles. This way I will have here the reading of the ILS and later here the reading of the VOR. So it can help us go through the chart faster. Good, I'm going to prepare the descent, so after reaching 19 DME out we'll descend down to 3,300 feet. I cannot select 3,250 feet, that's why I'm selecting a safer value, the immediate higher altitude. Good. And well, we'll everything is it's been quite quiet now, but all of a sudden everything is going to go very, very fast. Because when we turn, we'll have to switch from VOR to ILS navigation. At the same time, we'll have to descend to reduce to 180 knots, prepare flaps 15, everything in just a few seconds. Okay, so we're about to reach 19 DME out, 18.8, and well, there it goes, 19. So I'm going to turn by the right, heading west, 270 degrees. Level change down to 3,300, reducing 180, and twice F7 to select flaps 15. Good. Now I'm going to change my navigation from VOR to the ILS frequency. It obviously says there's a frequency disagreement, as I've already explained throughout the lecture. So change this to APP. All right, good. Now we are here reading the localizer and the glide slope indications. If you were to change the course to 292, which is the localizer course, what is this indicating us? It's clearly indicating that the localizer is south of our position and that we are flying below the glide slope. All right, since everything is very foggy, it's very important to have position awareness. We have to know where we are. We are currently over here, all right, and we are following this chart. We cannot go below the minimums, otherwise we may have a CFIT, a controlled flight into terrain event. Good. Now please engage the autopilot. In the autopilot, in the MCP, the APP mode. This will here pop up VOR lock in white and glide slope in white, and it will make the aircraft automatically capture the localizer and then later the glide slope as we approach the final approach point. All right, the final approach point on the chart, remember, is 9.7 miles from the runway threshold. Good. So now we are intercepting the localizer. Look how the VOR lock switched from white to green, and now without having to change the heading, the aircraft has captured the localizer and is turning right, intercepting the localizer. And now the glide slope, as we come into the threshold, the glide slope that is currently above our aircraft, we will get to cut it and then continue down with it. You see how the glide slope is coming down here, and as soon as it gets to this middle point, meaning the position of the aircraft, this glide slope will convert from white to green, indicating that we've captured the glide slope. So I'll prepare now the aircraft for landing. Go through the last of your checklist. The table 7 final approach point checklist, it says 145 knots, so I will reduce to 145. It says that flaps should be totally down, F8, and gear down, so letter G on the keyboard. We are currently intercepting the glide slope. Look how glide slope has been illuminated, and the aircraft is going to start descending from 3,300 with the glide slope. This is going to give us a rate typically provided by this chart for a ground speed of 140 knots of around 700-800 feet per minute. Okay, which is the variometer indication that we can read here. This is the radio altimeter. All right. Now, what do we have to do? We just have to wait and make sure that by the time we reach our minimums, which are 367 feet of barometric indication, we can see the runway. If we can't see the runway, I will disconnect the autopilot, present here, disengage, and I will manually land the aircraft. All right. This is something you'll do at the lab with the joystick. Good. So I'm totally established on the localizer and the glide slope. I'm perfectly on track. And we are 7.3 miles from the threshold, or 11.5 miles from Sierra November Romeo VOR. Good. Let's take a look at the aircraft from outside. Look, all the flaps are properly deployed. Landing gear is down. We are all ready for the landing. Good. Good, so here we can see some terrain, but we can't see the runway. 2,000 feet to go. If we take a look at the chart, we're going to follow this path, then we'll see a little bit of the sea. This is the Bay of Santander. This is Somo. And then across Somo, we will see, sorry, I think Somo is this here. But across this shore of the bay, we will supposedly see the runway threshold. So we cannot even see the sea yet. 1,500 of altitude. Still 1 minute to go, more or less. Okay, so 1,000 feet. Still flying with the autopilot. Be aware that with the landing gear down and all the flaps down, it's not flying at idle power, it's flying at 64% of N1, so it's quite noisy now. Good, so here we can see the bay. We can already see a little bit we can now clearly see the sea and the runway, so I'm going to disconnect the autopilot. With this precision approach, we've been able to go lower and thus see the runway. I will disconnect the auto throttle, so now I have the throttle, I have the full controls of the aircraft, and I'm going to try to land. Nice ship over there on the left. So we can read the PAPI. 2 whites, 2 reds means that we are flying on path. All red means too low. Good. So now I set idle power, and I let the aircraft get onto the ground. I flare, and then I bumped a little bit, and then I press F2 for the reverse thrust. There we go. And I can press the point button for the brakes. There we go. So this is it. This is how you finish your exercise. But not yet. You have to stop your recording, okay, to get the file. So go to FS Recorder, stop recording, and then on the desktop of your computer, you have to save your file. Let's say you save it like this, guardar. And then you have to convert this file into a TXT that you can open up with MATLAB or with whatever software you want to use for the treatment of the exercise. So you go back again to the folder we had, you open the FS recorder and you have to open the converter. Okay, so go to FRC converter and then say that you want to convert from FRC to text. Select yours, open it, and say that you want to create the other one with a different extension, and then you get the other one created. You can open it and check that you've saved all the parameters of your flight. Timestamps, latitude, longitude, altitude, these are all the values of your black box. Okay, so this is what you have to use to comply with the assignment that you have for this lab, that comes determined by the last page of the statement. You have to answer all these questions. Okay, so I hope this video has helped you through the exercise and through the navigation. I hope that it can clarify many doubts, that you don't have too many questions when we are at the lab. So, well, good luck, and see you at the lab then.